Welcome back. We are on video 4.2. So we're going to continue talking about the atom. And remember that atoms are made up of three subatomic particles: the electron, which is negative, the proton, which is positive, and the neutron, which is neutral. The electron's really small. The proton and the neutron are both relatively large, and they're about the same size. Not quite, but pretty close. The electron is negative, proton's positive, neutron's neutral. That's important to remember. Atoms are basically spheres. They're very, very small. And they're mostly empty space. So the electrons that are negative are in the electron cloud, and they travel around the nucleus. Since the nucleus has the protons and neutrons, which are positive and neutral, that means the nucleus is positively charged. Because matter is neutral, that means that the protons and the electrons, their charges offset. That is important. So, we know that protons and neutrons can be further broken down into something called quarks. If you go on to study chemistry in college or physics in college, that will be important. For purposes of this class, we're going to go with protons, neutrons, and electrons as our subatomic particles. So if you look at this chart, you can see where they are, what our symbol is going to be for each of them, and their relative charge. So the electron is negative, the proton is positive, and the neutron is neutral. If you look at this, protons and neutrons are each about 1 atomic mass unit, and the electron is a fraction of 1,840. So it's really, really, really small. So when I'm looking at an atom, its behavior is going to be explained by its neutrons, and not its neutrons, by its electrons. That is going to be really important. We're not going to really talk about protons and neutrons other than the fact that they exist much, again, until we talk about nuclear chemistry. But the electrons are important, and they are going to determine the chemical's behavior. So, since each element contains a unique positive charge in their nucleus, electrons determine behavior, the protons determine identity. So the number of protons in the nucleus identifies the element, and that is known as the element's atomic number. So if you look on your periodic table that you have, the periodic table has right now 118 elements on it. That's the one that I gave you. And if you look at it, you can see the chemical name up at the top. You can see the atomic number. Then you can see the symbol. And then you can see the average atomic mass. So for a hydrogen on your periodic table, it says hydrogen number 1, that H, and then 1.01. That's the average atomic mass. So this actually gives me a lot of information that I need. If you look at helium, its atomic number is 2. That means it has 2 protons, and its symbol is capital H, lowercase e, and then it has 4.00 as its average atomic mass. So what the atomic number tells me is the number of protons. One other thing to remember is that matter is neutral. So my number of protons is going to equal my number of electrons. So let's practice using our periodic tables. So we're going to look at instance B, and it says element PB, atomic number 82. So if I know the atomic number is 82, that means my number of protons is going to be 82. And that means my number of electrons is going to be 82. So the atomic number always equals the number of protons. And in an atom, when matter is neutral, it's going to also equal our number of electrons. So if I look on the periodic table, element number 82 with a symbol of Pb is called lead. So now let's look at example B. If I've got 8 protons, that means my atomic number was 8, And my number of electrons is also 8 because they are all equal to each other. If I look on the periodic table, oxygen is element number 8. It has an atomic number of 8. So that means that it's an O. That's its symbol. And its name is oxygen. And then let's look at C. So, question C, we've got 30 electrons, and since our electrons equal our number of protons in an atom, we're going to have 30 protons, and the atomic number is going to equal 30. So, what element is number 30? That would be zinc. So that's going to be Zn is its symbol, and its name is zinc, Z-I-N-C. Please try not to make spelling errors or symbol errors, because if you write ZR instead of ZN, that's zirconium and not zinc, and I would have to count that wrong. So, remember that all atoms of a particular element have the same number of protons and electrons. We find that from the atomic number on the periodic table. But the number of neutrons in the nucleus can differ. It can change. So the way I figure out the number of neutrons in the nucleus is I look at the average atomic mass. And if you notice, the average atomic mass is almost always a decimal. That's because atoms with the same number of protons but different numbers of neutrons are called isotopes. So this would be like somebody that has 4 neutrons, something that has 5 neutrons, something that has 7 neutrons. It's going to change based on, the mass is going to change based on the number of neutrons. The atomic number will always stay the same. So your number of protons will always stay the same, but your number of neutrons is going to change. So, when we are trying to figure out the number of neutrons, we're going to have to look at the mass number given to us, or figure out how to get the mass number. Because each isotope is relatively constant in abundance, and because neutrons change the mass, we're going to have a decimal most of the time on the periodic table, but not when we're talking about specific elements or specific atoms. Isotopes do typically have the same chemical behavior. So it's not that big of a deal if I'm talking about uranium-234 as opposed to uranium-235. One of them is better for making nuclear weapons, but they're not going to be that different than each other, just one more neutron. So the way that I figure out the number of neutrons is I look at the mass number, and the mass number equals the protons plus the neutrons. So, my protons plus my neutrons right here, 19 plus 20 equals 39. That's why that atom is called potassium-39. If I've got potassium-40, there's still 19 protons, but my number of neutrons has changed right there. That's why it's 40. If I've got potassium-41, I still have 19 protons. Now I have 22 neutrons. That's why it's potassium-41. If you look on the periodic table, potassium, which is element 19, it is, on the periodic table, it has an average atomic mass of 39.1. That is because it's a weighted average, which we're going to talk about. But I can figure out the number of neutrons based on the mass number. So let's look at this. Neon has an atomic number of 10 and a mass number of 22. So I can go ahead and figure out most of this without having to look at the periodic table. But how many protons does it have? I can look at the periodic table, see that neon is number 10. It has an atomic number of 10. So it has 10 protons, which means it's also going to have 10 electrons. And I know that those are always going to be equal to each other when I'm talking about atoms. But then the number of neutrons is going to be based on the mass number and the atomic number. So remember the number of neutrons. It's going to equal the mass number minus the number of protons. So that's going to be 22 minus 10. So I'm going to get 12 neutrons. So the way that I would name this isotope is I would name it neon 22. And its symbol would be Ne, capital N, lowercase e. And to designate that it's neon 22, I can put a 22 over 10 right here for the mass number over the atomic number. And that is how you figure out the number of subatomic particles in an atom. Thanks so much for your attention.